Welcome back to the Japan FinTech Observer. Get ready for a quick hit of the latest news in Japanese finance and fintech. We're diving into the headlines, breaking down the trends, and leaving you with the insights you need to stay ahead of the curve. Let's go.
At the beginning of July 2025, the Innovation Strategy Center of Japan's New Energy and Industrial Technology Development Organization, NEDO, published its Innovation Outlook version 1.0, outlining a new strategic direction for national research and development. It pivots from a traditional linear model of research and development to a dynamic, mission-driven approach aimed at tackling complex societal challenges and fostering transformative innovation. The Outlook identifies key frontier domains, high-priority areas for investment and development, across 6 major technological fields, determined by a backcasting methodology that starts with a desired future vision for society. For those with little time, allow us to summarize the key takeaways first. Strategic pivot to transformative innovation. NEO is shifting its strategy from technology-focused research and development to a mission-oriented approach. The goal is to address overarching societal challenges like climate change, an aging population, and economic security by creating new social systems and industries, a concept termed transformative innovation. New Innovation Strategy Center and Innovation Outlook. The former Technology Strategy Center, TSC, has been reorganized into the Innovation Strategy Center to lead this new agenda. The Innovation Outlook is its flagship publication, designed to identify and communicate priority research and development areas, frontier domains, to a wide range of stakeholders, including government, industry, and finance. MFT framework as a core methodology. The Outlook uses a backcasting model based on the Mission Market Function Technology MFT framework. It starts by defining a desired future social vision, mission, identifies the necessary functions and values to achieve it, function, and then determines the technologies required, technology. This problem-driven approach is a departure from a purely technology-push model. DARPA-style management. The Outlook advocates for an agile, flexible project management style inspired by the US DARPA model. This involves empowering program directors with the authority and resources to guide projects from ideation to implementation, with a greater tolerance for risk and the ability to adapt to changing circumstances. Identification of 12 key frontier domains. The core of the Outlook is the identification of 12 priority areas across 6 major technological fields for Japan to focus its innovation efforts. These are sustainable energy, underground untapped resource utilization, e.g. next-gen geothermal, natural hydrogen, long-term energy storage for variable renewables, environment and chemical, base metal recycling, radical shift from fossil carbon sources for chemicals, agri-food tech, health food tech, personalized nutrition, forest resource circulation, digital, power saving and high-speed information processing for AI, social infrastructure monitoring and forecasting, automation and labor-saving digitalization, materials, extreme materials, e.g. high-temperature superconductors, high-performance optics, bioeconomy, shifting from fossil to renewable raw materials, advanced biomanufacturing, advanced sensing and control of biological and environmental information, living materials, devices. Now, let us break down these areas in more detail. A new mandate for Japanese innovation. The Innovation Outlook version 1.0 represents a fundamental re-evaluation of Japan's national innovation strategy, spearheaded by NEDO's newly established Innovation Strategy Center, a reorganization of the former Technology Strategy Center. NEDO Chairman Tomotsu Saito frames this initiative as a necessary response to an era of profound and complex societal challenges, including climate change, a declining birth rate and aging population, and mounting threats to economic security. The Outlook argues that addressing these issues requires more than incremental improvements to existing technologies. Instead, it calls for transformative innovation, a paradigm shift focused on creating entirely new social systems and industries. This involves moving beyond the traditional linear model of innovation, where research and development progresses sequentially to commercialization, and adopting a more agile, iterative, and holistic approach. This new model emphasizes the concurrent development of technology, business models, rules and standards, and social acceptance to ensure that technological breakthroughs translate into tangible social and economic value. The Innovation Outlook serves as the primary instrument for this new strategy, aiming to provide a comprehensive, forward-looking map of the technological landscape and identify the most critical frontier domains where Japan should concentrate its efforts. It is intended not only as an internal guide for NEDO and a policy-making tool for the Ministry of Economy, Trade and Industry, but also as a public-facing document to stimulate discussion and collaboration among a wide array of stakeholders, including industry, academia, finance, and international partners. Methodology: from a vision of the future to technological frontiers. The Outlook's methodology is rooted in a backcasting approach, beginning with a clear vision of the future it seeks to create. This vision is based on previous NEDO reports and defines a prosperous future structured around 6 core value axes: life satisfaction, economy, environment, social inclusion, governance, and infrastructure, and 12 corresponding social images. These images describe a desirable society, such as one where everyone can realize their potential, sustainable economic growth is achieved, and a strong and resilient social infrastructure is realized. This high-level vision serves as the mission market anchor for the Outlook's central analytical tool, the MFT, Mission Market Function Technology Framework. From the desired social mission, the framework identifies the necessary functions value required to achieve it. These functions represent the specific capabilities or values that a new system must deliver, such as reducing GHG emissions or ensuring food security. Finally, the framework identifies the technologies that can enable these functions. This structured process allows for a systematic exploration that connects high-level societal goals directly to specific technological pull, research and development areas. The frontier domains are selected from this analysis based on a comprehensive evaluation against 5 key criteria: future potential, growth and societal impact, technological and conceptual innovativeness, Japan's existing competitive advantages, the difficulty for the private sector to pursue alone, and relevance to critical economic security. This rigorous, vision-driven methodology ensures that the identified domains are not only technologically promising, but are also strategically aligned with Japan's long-term national interests. Frontier Domain 1: Sustainable Energy. In the realm of sustainable energy, the Outlook identifies 2 critical frontier domains aimed at addressing Japan's dual challenge of achieving carbon neutrality and ensuring energy security in a country with limited land and natural resources. The first domain is the utilization of underground untapped resources. Recognizing that the expansion of solar and wind power is constrained, NEDO proposes a focus on harnessing Japan's significant geothermal and potential hydrogen resources. This includes developing next-generation geothermal technologies like enhanced geothermal systems and closed-loop systems, which could unlock energy from areas previously considered unviable, as well as exploring supercritical geothermal power. Furthermore, it highlights the emerging potential of natural hydrogen, a carbon-free energy source that may be generated through geological processes within the Earth's crust, presenting a new avenue for domestic energy production. The second frontier domain is long-term energy storage for maximizing the use of variable renewable energy. As solar and wind power become more prevalent, their intermittent nature creates significant grid instability and a mismatch between supply and demand, particularly on a seasonal basis, e.g. solar surplus in spring, high demand in winter. While lithium-ion batteries are effective for short-duration storage, the Outlook identifies a critical gap in technologies capable of storing massive amounts of energy for days, weeks, or months. To fill this gap, it proposes prioritizing research and development in long-duration storage solutions such as advanced thermal energy storage using materials to store heat and mechanical storage systems, which are essential for absorbing surplus renewable energy and ensuring a stable, year-round supply of carbon-neutral power. Frontier Domain 2: Environment and Chemical Industry. The environment and chemical sector focus is on establishing a true circular economy driven by the need to mitigate climate change and reduce dependency on volatile international resource markets. The first frontier domain in this area is base metal recycling. The production of primary base metals like steel, aluminum, and copper is highly energy intensive and a major source of CO2 emissions. The outlook notes that recycling these metals is not only crucial for decarbonization, but also for enhancing economic security, as Japan relies heavily on imports for these materials. The challenge lies in developing innovative technologies to effectively process low-quality scrap, which is often contaminated with impurities, into high-value materials. This requires advancements in automated sorting, using AI and advanced sensors, refining processes to remove unwanted elements, and materials science to ensure recycled metals meet stringent performance standards. The second domain is a radical shift from fossil carbon sources for chemicals. The chemical industry is deeply dependent on fossil fuels, both as an energy source and, more fundamentally, as a carbon feedstock for producing plastics, polymers, and other materials. To break this dependency, the outlook advocates for a comprehensive transition to alternative carbon sources. This includes advancing chemical recycling technologies that can break down waste plastics into their constituent monomers, expanding the use of sustainable biomass, and developing and scaling up carbon capture and utilization technologies that treat CO2 as a valuable raw material for producing fuels and chemicals. Realizing this vision requires not only technological breakthroughs, but also the creation of new markets and value chains for low-carbon and recycled products. Frontier Domain 3, Agri-Food Technology. In the agri-food sector, the outlook targets the intertwined challenges of global food security, Japan's low food self-sufficiency, and its aging agricultural workforce. The first identified frontier domain is health food tech. This moves beyond simply securing a sufficient quantity of food to focusing on the quality of food and its impact on human health and well-being. The vision is to create a system of personalized nutrition where an individual's genetic information, metabolic data, and lifestyle are analyzed to provide tailored dietary recommendations and functional foods. This approach aims to extend healthy lifespans and prevent lifestyle-related diseases, leveraging Japan's strengths in food science and healthcare. The second frontier domain is forest resource circulation. Japan is a heavily forested nation, yet its forest resources are underutilized. This domain proposes leveraging these resources as a key component of both environmental and economic strategy. This involves using forests as a major carbon sink through sustainable management and reforestation, as well as developing high-value products from wood. Key research areas include creating novel materials from wood components like modified lignin for applications in electronics and automotive parts, and promoting the use of biochar, a charcoal-like substance made from biomass, to improve soil health and sequester carbon in agricultural land. This integrated approach aims to create a virtuous cycle that supports decarbonization, revitalizes rural economies, and enhances sustainable material production. Frontier Domain 4, Digital Technologies. The Digital Technology chapter addresses the transformative potential and inherent challenges of the ongoing digital revolution. The outlook identifies three interconnected frontier domains. The first is power saving and high-speed information processing. While generative AI and other advanced digital tools offer immense economic and social benefits, their development and operation consume vast and rapidly growing amounts of electricity, posing a direct threat to carbon neutrality goals. This domain prioritizes the development of a new generation of energy-efficient computing hardware and software, including novel AI chips, neuromorphic computing, and alternative computing paradigms that can drastically reduce the power consumption of data centers and edge devices without sacrificing performance. The second domain is social infrastructure monitoring and forecasting. In an era of increasing climate-related disasters and aging infrastructure, this domain focuses on creating resilient social systems through the use of advanced digital twin technology. By integrating data from a vast network of sensors on satellites, drones, and ground infrastructure into sophisticated simulation models, it becomes possible to monitor the health of bridges, roads, and buildings in real time, predict the impact of natural disasters like earthquakes and typhoons, and optimize maintenance and emergency response. The third domain is automation, labor saving, and digitalization. To counter Japan's severe labor shortages across sectors like manufacturing, logistics, construction, and healthcare, this domain advocates for the development of advanced AI agents and robotics. The goal is to create highly capable and adaptable systems that can learn from human experts, perform complex physical and cognitive tasks, and collaborate seamlessly with human workers. This includes developing sophisticated humanoid robots and user-friendly interfaces to accelerate the deployment of automation in a wide range of real-world environments. Frontier Domain 5, Materials Science. The Materials Science section underscores the role of advanced materials as a fundamental enabler of progress across all other technological fields. The Outlook consolidates this into a single high-impact frontier domain, extreme materials. This domain focuses on the discovery and development of materials that can function reliably under extreme conditions, such as ultra-high temperatures, extreme pressures, intense magnetic fields, or highly corrosive environments. These materials are essential for pushing the boundaries of what is possible in next-generation energy, aerospace, and industrial applications. The Outlook specifically highlights two priority areas within this domain. The first is high-temperature superconductors. These materials, which can conduct electricity with zero resistance at relatively higher temperatures than their predecessors, are critical for developing powerful compact magnets for nuclear fusion reactors, like tokamaks, next-generation MRI machines with higher resolution, and highly efficient motors for electric aircraft. The second area is high-performance optical materials. These are materials and devices, such as laser crystals and specialized optics, capable of handling extremely high-power lasers. Such technology is crucial for applications ranging from advanced manufacturing and materials processing to space-based energy transmission and the removal of space debris. Japan's historical strength in materials science and precision manufacturing positions it well to lead in these demanding fields. Frontier Domain 6, Bioeconomy. The Bioeconomy chapter outlines a vision where biological resources and biotechnology become a central pillar of a sustainable economy, moving beyond the fossil fuel paradigm. Two frontier domains are identified to drive this transition. The first is the shift from fossil to renewable raw materials, focusing on the advancement of biomanufacturing. This involves harnessing the power of biotechnology, using engineered microorganisms like bacteria and yeast as cellular factories to produce a wide range of chemicals, fuels, and materials from renewable biomass instead of petroleum. This requires innovation at every step of the process, from designing highly efficient microbial strains using synthetic biology to developing cost-effective methods for processing biomass and purifying the final products. The second frontier domain is advanced sensing and control of biological and environmental information. This visionary area aims to merge biology with electronics and materials science to create living materials and living devices. These are systems that use biological components, from engineered cells to proteins and DNA, to perform sophisticated functions. Examples include biosensors that can continuously monitor a person's health status in real time, smart bandages that detect infection and release antibiotics, and environmental sensors that use microorganisms to detect pollutants. This domain leverages the inherent specificity and efficiency of biological systems to create highly sensitive and responsive technologies for healthcare, environmental monitoring, and beyond, opening up entirely new technological possibilities. An agile, mission-driven future. In its concluding chapters and remarks, the Outlook reiterates the necessity of a new implementation philosophy to bring these ambitious goals to fruition. It acknowledges that exploring these frontier domains involves significant technical and market uncertainty. To navigate this, NEDO advocates for a management style inspired by DARPA, centered on agile and empowered program directors, PDs. These PDs will be responsible for leading projects with a holistic view, overseeing not just the technology, but also the surrounding ecosystem of policy, standards, and market creation. This model embraces flexibility, allowing projects to pivot or be restructured as new information emerges, and accepts a degree of failure as an inherent part of pioneering high-risk, high-reward innovation. The outlook is presented as a living document, with NEDO committing to annual updates based on technological progress, shifts in the global landscape, and feedback from stakeholders. By openly sharing this strategic vision, NEDO aims to catalyze a national conversation and build a broad coalition to drive the transformative innovation Japan needs to secure a prosperous and sustainable future.